This is 6-3 alpha. Okay. So binomial and geometric distribution. We're going to focus on the binomial and get the geometric next week. So you need to understand something. Ready? Take out your calculator. You go to second bars, and you're familiar with this. We've been doing normal CDF. Yes. And what's happening is normal CDF refers to a continuous distribution. If you look at the bottom of this page, whoops. If you look at the bottom of the page, we have binomial. Now, you got to be careful now. You're typing the right thing. Choice A is a binomial probability distribution function. B, binomial cumulative. So if we want the area of the curve up to and including something, you have to choose the cumulative choice. You're thinking in context of what you're being asked. So back here, for what you're familiar with, we've been using normal CDF because normal PDF just gives you the height of the standard normal curve at a specific input. We're not interested in the height of the curve, which is the area of the curve up to including that vertical cutoff. So what we're trying to point out to you is this. What you've been doing refers to a continuous variable. It takes on values between the whole numbers. With binomial distribution, they're discrete. Your only answers, the only outputs you can get are whole numbers. They're two different distributions. It depends on the context of the question. Now, these questions, they're groups. You're going to get all these discrete questions together. But in May, you're not going to be stratified that way. You're going to have to identify what the question is asking. So we're going to use binomial expansions, which you're familiar with from pre-calc. This is the language a college board uses. It's kind of old school. You might see it in your parents' textbooks lying around, where they stack this. Here's how you're used to seeing it. N choose K. This is giving you what? It's giving you values in Pascal's triangle. So if I want a binomial probability, I have N choose K what? Well, this part is without replacement, and this component is with replacement. It's the probability of success, how many successes we want, times the probability of failure, how many times we fail. Okay? Then this itself is just this algorithm. So just to review, I don't know how well you can see this at home. Pascal's triangle looks like this. This is the first, ready? 3 rows of Pascal's triangle. Because this is row 0. Row 0, row 1, row 2, row 3. Why do I call that row 0? Because this can be rewritten as 0, choose 0. So on your calculator, ready? Now, it depends which calculator, what operating system you have. So if I go here, and I go to math, Sorry, second step, math. Math PRB. Okay, here we go. Math PRB, ready? 3. Now, make sure you understand what the choices are. 3 is a combination. 2 is a permutation. Permutations mean that order matters. Combination order doesn't matter. So go over here and I say, all right, if I want 3, in this calculator, I put the numbers in after I type the choice. 0, choose 0, enter, gives you a 1. That's the 1 at the top of the triangle. That's row 0. In row 1, 1, choose 0, 1, choose 1. Row 2, 2, choose 0, 2, choose 1, 2, choose 2, and so on. So here it is with the combinatorics. There it is the way you're used to building it, numbers. But if I went here and say, let's say we have 3 people. 3 people in the middle of the road. Ready? Stand up. So we got 3. Okay? And we're going to choose 2 of them. What we're saying is like, leave 1 out. Make sense? So if I choose 2, how many ways could I do that? The same way I could leave 1 out. There'll be 3 ways. What's that? 3, choose 2. So 3, choose 2 would be that. Listen, now we don't have to have you sit down. You get, right? Like 1 person would sit down and come. It would be 3 times with 2 people standing. So in the calculator, if I go 3, choose 2, you get a 3. Right? If you go three, choose 2 for a permutation, you get a 6. Why? Because when Jordan was sitting, they were taking choose 2 people at a time. The permutation would count. Victoria, Larissa, separate from Larissa, Victoria. The order matters. We're not doing permutations. We're not. We're doing combinations. Okay, so on the calculator, you need to be aware of this. Stay away from that 2 button. It's going to give you an answer, but it doesn't apply to what we're doing. So let's come up with like a scenario that we can understand before we turn you loose on the 3 questions we're sending you to, all right? So it's 1 data set. So let's say, what is the probability? This is a question that's a pre-calc question. It's simple. That I have a fair die. What's the probability of a fair die and I roll it 3 times and I get exactly 1, 1. What's the probability of getting a 1? 1/6, yes? What's the probability? Is it 1/6 plus 1/6 plus 1/6? Is it a 50% chance? You have this fair die, 1 die in your hand. We're going to roll it 3 times. What's the likelihood you get exactly 1 and only 1, 1? Exactly 1, 1. Well, we would use this algorithm. Ready? Right here. So we would say the probability of success is 1/6. Yes? How many times you be successful? Once. What's the probability of failure? 5/6. How many times you're going to fail? So what? 3 rolls and a done. You're going to fail twice. Except what? We could succeed on the first roll, or the second roll, or the third roll. So there's 3 ways that can happen. So we would say 3, choose 1. This is the probability of getting exactly 1. You roll the dice 3 times. Like you go here on the calculator. Ready? Three, choose 1. Success is 1/6. I'm going to succeed once. Failure is 5/6. I'm going to fail twice. Is that an answer you're going to guess? Yeah. So now what? Or you could go here. There's a shortcut, and the shortcut's this. Second bars, watch what I'm doing. I'm going to go to PDF. Not C, not cumulative. I want exactly 1 success. So we click on A. You get prompted. Now, if you have an older calculator, you're not getting the prompts. But you're typing them in this way. How many trials do we have? 3. What's the probability of success? 1/6. How many successes do we want? 1. So if you have an older calculator, you have to know what this prompt is. You're just going to get this. If you have the older version, you're just getting this, open parentheses. You have to put in there trials, comma, probability of success, comma, how many successes. Same answer. Now see if this makes sense to you. Suppose I did it wrong. Watch what happened. See the only difference between those two is that letter. Yes? Enter. Whoa. Answers are way different. What? Let's work backwards. Let's play Jeopardy. The answer is 92.5%. What was the question? Okay, right. If that were true, then these two would have to add up to 1. So that's a discrete choice. You got 1, 1 in 3 rows, or you did not get 1, 1. You got either 0, 1, or 2, or 3. They would have to add up to 100, so that's about a little less than 66%. What do you think this is telling you? It's cumulative. So it's taking this and adding 0 successes. It's cumulative. 0 successes or 1 success. Meaning this is discrete. It's not continuous. So there's, when you roll a die 3 times, there's 4 things that can happen. 0 successes, 1, 2, or 3. Just like there's 4 things that can happen when you roll it 3 times. Just like in row 3, there's 4 entries. So, let me pause this for a second. So we're going to ask you to go to 3 problems that deal with 1 data set. 77, 81, and 85 deal with the same data set. Okay? If you have a question about the calculator key sequences, then stop. Okay, so let's look at this. 77. Now, you wouldn't know to do this, but said, is this a binomial scenario? We're going to walk through this together. And they're saying the probability of success was 44%. Well, the answer is yes. Answer the question is why? Because it meets those bullet points, which were, is it binary? Yes, the elk lives or dies. Is it independent? Yeah, the fact that one elk lives doesn't affect the next elk. Okay, is the probability fixed in advance? 44%, and it says that there's 7 to choose from. So yes, it meets that criteria. So we can do this on the calculator. So a couple things on shortcuts. Take out your calculator, and we're going to go to and take this stuff out of here. Now, do you remember how we did this? What's in here in list 1 is a sequence of the terms from 0 to 25 with a delta and a change of 5. Which you can type by hand. And here we're going to remind you how to do this. We're going to put in 0 through 7. You could probably type it faster, but if it was 0 through 50, you couldn't. So we go, second quit, and this is on the PDF. You don't need to take notes of this. You go back to the PDF. We go too fast for you. Second stat, ops, we want a sequence, 5. So we're saying x, because it's linear, the variable is x, start at 0, end at 7, make the step worth 1. We're going to store that in second 1. So those are the probabilities. Oh, I'm sorry, those are the possible outcomes. 0 elk survive, through all 7 of them survive. Yes? But instead of doing all the individual calculations by hand, one at a time, we can do this in the stat editor. So we go to stat, edit. Here's what we want in list 2. In list 2, we want, ready? The distribution, it's binomial. Well, we want each individual outcome 0 through 7. We don't want cumulative. How many trials? 7. What's the probability that the elk survives? 44%. What's our X value? It's 1. Push enter. Oh, did it work? What happened? Should have worked. What do I do here? All right, I just stored it. We'll do it on the home screen. Sorry. Second distribution, back where we were. Paste it and just store it in second 2. Same thing. So now they're there. Stat, edit. There are all the individual probabilities. Think what this means. The sum of list 2 has to be equal to 1, because they're the only things that could possibly happen. You've got these 7 elk, either 0 survive, or 1, or 2, up to 7. If I go back here and say, what's the sum of list 2? Get a 1. Okay. And then the second question saying, what's the probability exactly for survive? We could do it this way. Ready? We could go math, PRB, combination. Ready? There's 7. Choose 4. The probability of success is 0.44. How many times are you going to be successful? 4 times. What's the probability of failure? 0.56. How many times are you going to fail? 3 times. We would get that answer. A little more than 23%. But if we go here, here is the answer. Because they're all there. You put them in the list. So that's the first 2 problems. If you're at home, you're dismissed to go do the exit ticket. If you're in here, we're going to do the last one. If you're at home, we will see you on, we'll see you tomorrow for the beta list. So there's the 23%, a little over 23% for 81. And then 85 says, more than 4 elk, more than 4, which means either 5 survived, or 6, or 7. Yes? So I can look at it here and go to the calculator and say, add these 3 entries, That's 5, or 6, or 7. What are we talking about? Well, that's about 12. It's about 14% chance. Make sense? We add this 3 up. But you don't have to do it that way. You could. It would be more efficient to do this. Let's do the probability that up to and including 4 survive. If we do that, which is cumulative, you get 85.9%. So that includes everything except what we want. One, take away that's the 14%. Because the issue is, we know that this is what we want. We want the sum of these 3. But we know the sum of the whole list is 1. So if we do binomial CD, it'll give us the answer up to 4. Subtracting these values from 1 would give us the sum of those 3. Okay?